Hello and welcome to today's video. This is video number 16 in the journey. Let's start our daily challenge. Okay. Question number 93, restore IP addresses. A valid IP address consists of exactly 4 integers separated by single dots. Each integer is between 0 and 255 inclusive and cannot have leading zeros. Okay. For example, 0, 1, 2, 2, 1, 2, 0, 1. Some are valid IP addresses, but okay, so this one doesn't work because it has a leading 0. This one doesn't work because it is greater than 255. And this one has a weird character. Given a string S consisting of only digits, so this will never be the case, of only digits, return all possible valid IP addresses, then can be formed by inserting dot into S. You're not allowed to reorder or remove any digits. You may return a valid IP address in any order. The context to this question is the previous day. We had a solution that involved backtracking, essentially making all combinations of all non-decreasing combinations of an array. I'm thinking that somehow here I can also backtrack, which actually what it actually does is create different combinations of the positions of these dots such that, and I'll have a condition that makes sure that the separation is valid. I'm thinking that already it seems like a pretty decent solution. The number of digits given cannot be infinite and cannot be more than 16. So this backtracking solution should do the job. Let's set up our let's set up how it pretty much how the previous questions backtracking implementation was done. Backtrace, actually it's called backtrace, and let's implement the backtrace function. So I'm thinking that if I'm going to be making the output solely by the position of the ones of the dots, then I can just pass points into my backtrace function and starting with nothing and populate it until I have 3 of a until the points arrays of length 3. I could probably do something. So for example, if len points is equal to 3, that means that I have I've reached a potential solution. And potential solution. And how the rest of this was structured was we have a for loop that iterates through different next positions that this one or this dot could take, starting obviously starting not with the 0th position. So let's see if we can say this is going to be okay. So we need a starting point. starting point is going to be points, the last point that was given, if points, else probably a 0. And we're going to iterate through start plus 1 until length of s, right? So now that are iterating through all the different positions that that dot can take, from 1 being here to the end, let's implement the condition by which we will either add a 1, or I keep on calling it ones, add a dot, or not add a dot. That's going to be let's call this net, I'm pretty sure it's called. It's going to start from start until the I that we're currently looking at. So start being 0, from 0 to, now we'll try to find all the different combinations of, well, we'll try to implement the if statement that's going to dictate whether the net is valid or not. If int net is greater or equal to 0 and int net is smaller or equal to 255, then points append I, then call backtrace with the new points, and since we're on the same level, pop. Let's see. This should already, let me see, should this already give us at least something? No, it should not give us anything yet, because ants is never populated. It's never added to. So I guess here, let's say that if we already have 3 dots, if len points equals 3, let's say ants append or add. Okay, and now we need a function to construct this string. Let's say that for point in points, this is some string manipulations, pretty trivial, but could take a couple of minutes if you're new to this. Let's say that for points, we would say that we'll call it new. So let's call it solution equals s, and then solution is equal to solution, where is going to be the point? Where is going to be the starting point? From 0 to the point, plus dot plus solution, and this is going to be point and on. Point and on, and finally answer add solution. Okay, let's see what happens out of this. Alrighty, so we are getting something already. Seems like we are completely skipping the so since once we've added 3 dots to our solution, we are completely skipping the checking of the rest of these things. And what I'm thinking we could do is, right off the bat, what if we do for. What if we add a fake dot? A fake dot that actually will just mean that we have found a solution. Thinking if I can knock out a couple of things with this approach. Let me do 3 for now and just implement the checking of this last number by hand. I'm going to say that if len, let's have another net here. If net is equal to start and to len of s. So a little something. If len of net is greater than 1, actually, yeah, we have our net. Let's do this, that if net, actually just this should be good enough. Let's run this and see if we're getting something more sensible. We're almost getting something more sensible, but pretty sure that what is going on here? Why am I, when I'm hitting that the length of points is 3 and the net why am I adding this huge number to the back of I'm adding this because 111 is less than 255, so it's technically valid, but why am I not capturing this whole number? It is greater than maybe I'm not constructing this correctly, since what if I'm thinking what I'm thinking is happening is that I'm manipulating this solutions string and I'm manipulating it and then assuming that its position doesn't change when it actually does. And there we go. This is our first correct solution. Wrong answer. What happened here? Am I missing a condition? Test case 3. Wrong answer. Right. I think we're almost pretty much there. We have solutions. Trailing zeros seems to be the issue that I'm having. Trailing zeros are, how would I check that? I would have to be checking it as I'm doing this step. Do I have to do it in both steps? Do I have to say that if len of net is greater than 1, so it's a 2-digit, if len is greater than 1 and net 0 is equal to 0, return. Let me add this same. Let me add this same thing here. Sweet. Okay, we have a solution. Let me see if this will work for 4 right away. What I really want to do is I want to eliminate having duplicate code. Although this is pretty, if you check the previous, let's submit this first. Wrong. What? If you check the previous day 15, you'll see that the structure of this backtrace is almost identical. We have an answer set. We have a function called backtrace. There it was called something else. And then within backtrace, we enumerate all the different locations that something can be. Previously, in the question day 15, it was the combination of zeros and ones within a certain substring. Here, it's the positions of zeros. Whether the position is going to be 1, 2, 3, or 1, 2, 4, or 1, 2, 5, and so on. How would I eliminate having to do this twice? If I have 4 as my final step, then I could say that could I say that if I have 4, then remove the, first of all, check that there's nothing after the last dot. Let's check that. How would we check that? If there's, if length is 4, we already have if s start does not equal a null string, then return. And that would prevent, we won't have to do this, I believe. We won't have to check if the constructed net is valid. That would be one change. The other change would be that we would never call this on a function that, or on a net that doesn't fit these criteria. So we actually don't need this either, I believe. Let's see if this works. Points. For points, let me exclude the last one. It's the way to exclude that, I believe, is to do this. You're excluding the last. Why not just have it be a constant? So the length is of 3, so this is what I need. Does this work remotely? Output? No, it does not work. Print. What should I be doing here? Maybe print solution. Is this a valid thing? Solution, we have a ton of solutions. Let's submit it with the previous response, and the previous response, and I'll just check that. Where did I go wrong? Where did I just miss this? And I will compare with an existing solution to what it should be. Where did I add this? This is what I did wrong. That was one thing, and then the other portion that I changed was this. Sweet. Okay. Oh wow. Okay. Nice. So actually beats about 50%. Okay, not bad. Let's find another solution that does almost the same thing, but maybe does it a little bit more cleverly. That is hard to look at. Sections, they claim they treat them as sections. None really that are DFS. Interesting. I cannot find a solution that is the same. It seems like none of us have really the same approach. Interesting. Usually back tracing for these sorts of questions, I think, is the right approach. Anyway, okay. This actually works for me. This is a bit ugly, so I would probably spend some more time figuring out how to get away with just doing 4 points to getting rid of this double check here. However, the solution is valid, and yeah, that's it. I think let's end it here. If you want something similar to this question, take a look at day 15, previous day. Leetcode seems to have them almost repeat the same topic over and over again after question by question, so they're similar. Anyway, thank you for watching. Catch you next time.